When you have something like this, e of a of x, this is a property where you can take a out and it stays like this. So let's say this would be 4. So let's say something would be like, let's say 4x. This is the same as having 4e of x. Okay, this is the first one. The other one that you need to be aware of is when it involves variance. So if you have a variance of a constant like this, the constant comes out but squared, so it stays like this. Here we have variance for x, 4 comes out squared, so that's 16 v of x. This is the second one that we need to know. So let's say now we have a problem where xi follows a normal distribution where our mean equals to 0 and our variance equals to 5. Remember that if they don't tell us anything, you just assume it's the variance and not the standard deviation. And they tell us that I is true for I equals from 1, 3, and 4. They're also saying that all random variables are independent. Okay, now we have this information. And they're going to ask you something like this. Derive the value of k. You'll find that they will show you a couple of problems where you have k that you don't know and you need to use some of the properties in order to solve the problem. So let's say for our first problem you are asked something like this. P2x1 minus x2 is greater than 3, and that is equal to k. How do you find the value of k here? Feel free to pause this video and try it for yourself. The way for us to solve this is by using the properties just like we talked about. One of the ones that is important to know in order to solve this problem is that if xa plus or minus xb follows a normal distribution, this means that the mean of a plus or minus the mean of b also follows a normal distribution. So we'll have something like this. Plus, remember this plus, it's not plus or minus, it's just plus, standard deviation of b as well. So what this means is that if you look at this, you have x1 and x2. And we know that our xi follows a normal distribution. Now that we have a couple of properties, let's start solving this problem. We start by solving the variances. The first one, vx of 1, you notice that we have 2 there. So the variance of 2x1, we've seen that 2 comes out squared. Variance of x1, that is equal to 4vx1. But notice that here we have 5 there. So that means that our specific example, it's 20. For the second one, notice that we don't have anything inside there. We only have a minus sign, but we know from the properties that it really doesn't matter if it's plus or minus, it will be always plus. So this means that the variance of x2 will be 1. So here we have this expression and we need to plug in the numbers in order to use this expression and have access to finding out the value of k. So what we have here essentially is as follows. 2x1, let me change colors here real quick. So we have here 2x1 minus x2, according to this property, follows a normal distribution where the mean of both plus or minus, and we've seen that the mean is 0, so it's 0 minus 0. And we've seen that in this specific instance, we have one that has a constant plugged into it. And from our math, we've seen that it's 20 plus 5. The next step is to standardize our distribution. So instead of having different variances, we're going to have 0, 1. In order to do that, we need to standardize our distribution. And we do that by using the following procedure. So P of z is greater than 3 minus 0 over the square root of 25. And this is the same as having P z greater than 3/5, because 3, the square root of 25 is 5, so 3/5. And this is the same of having, remember that when you have something that is greater, you do the reverse process. So here, what we are doing here essentially is 1 minus the probability of z being less than 0.6. It's 3 divided by 5 is 0.6. By checking our z table, you'll find that this is the same as having 0.7257, so which will give us the result of 0.2743. So our k is equal to 0.2743. Let's say we are now asked what is the probability of x squared plus x2 squared plus x3 squared is greater than k. And this is equal to 99%. How do you solve this? There is a property that says that if x follows a normal distribution in standardized form, this also means that x squared follows a chi-squared distribution with 1 degree of freedom. So the first step that we do here is standardize this distribution in order to get to this step. How do we do that? So let's begin. So the first step is getting, let's say, x1. We start with the first one. So it follows a normal distribution, 0, 5. And we need to standardize this. This means that x1 minus the mean over the square root of 5 follows a normal distribution 0, 1. And since all terms are the same, this also means that this holds true for all of them. So x1, x2, x3 all follow a normal distribution in standard form. The next step is to get the constant outside and get the expression in this form. We have it as square root, so we need to square all these terms and get the constant out. So by doing that, we're going to get this as follows. 1/5 multiplied by x1 squared by x2 squared by x3 squared. And all this is greater than 1/5 k. We get the 1/5 k here because we have the 1/5 k here as well. And this is equal to 99%. So if we have this expression, this means that we can now use the property. We can now say that the probability of chi-squared distribution with 3 degrees of freedom is greater than 1/5 of k, and that is equal to 0.99%. And if you check the table, you're going to find that the chi-square for v equals 3 and the probability of 99% is going to be equal to 11.5%. So what this means is that you're going to get 1/5 k equals to 0.115, and getting this one there, k is equal to 0.575. Let's look at another example. Sometimes you see something like this. You have xi is less than k, then you have square root of x, okay, squared, x3 squared. And this is, let's say, at 10%. When you have a situation like this, where you have x squared, and then you have a k here, usually it's a situation where you can use this following property. T is equal to z, x over k, the square root. And we are going to use two properties here. X follows a chi-squared distribution with k degrees of freedom, the same k that you are seeing here. And z follows a normal distribution, 0, 1. These are the two main ones that we are going to use here. How are we going to solve this one? So we are starting off with the first one on top. The first step is to normalize it, because we need to get it in 0, 1. Let's say our example, I didn't write it here, I'm going to write this down now. Let's say we started with something like this. So it's 0 and 5 as variance. Whenever they don't tell you if it is a standard deviation or variance, just assume variance right out of the get-go. So in our specific example, in order for us to normalize this one, so with the first expression, it's x1 minus 0 over the square root of 5. Now this follows a normal distribution, 0, 1. And the second one, as we have seen from previous examples, we take the variance out. We already did the math for previous examples, you can check it. So we're going to get something like this, x2 and x3 squared. And this follows a chi-squared distribution with 2 degrees of freedom. Now that we have these expressions, this one and this one, essentially what we're going to do is kind of plug those in the property that we see on top. So on top, we're going to do x1 divided by the square root of 5. This is our z1. This is the z1. And on the bottom, pay attention to this one so you don't get overwhelmed with math, because sometimes they want to throw some weird examples to throw you off. So this is how this works. We're just changing this x with this expression. So x squared, then we have the other one, so the 3, x squared as well, divided by 5. Nothing changed here, it's the same thing. And over, this is the part that you need to pay attention. We have 2 degrees of freedom. And we talked about in the beginning that k reflects the degrees of freedom that we have. So since we have 2 here, we're going to write 2. And we have a square root here, so just get the square root of the whole thing. And now we are in the simplify phase. The first thing you need to do, and usually in the exercises like this, they are more interested in seeing if you understand the properties more than the math. So usually you need to, at this stage, find things that you can kind of simplify. And we have a square root of 5 here, and we have a square root of 5 here. So you can get rid of these two. And this one, because this is on top, it can go on the bottom. So we are now left off with as follows. T is equal to the square root of 2 x1 divided by the square root of 2 squared plus square root of 3 squared. So these are the two ones, and this follows a t distribution with 2 degrees of freedom. Now we're going to use a property that says that the probability of t being less than, remember that we had 2k, so this is what we had from the previous expression. This is equal to 10%. This is what we had from the problem. Now you will check the table for these values, and the t-table usually presents the values to the right part. But you can solve the problem because the t-table is symmetrical. What this means is they're asking you the values to the left. But because we have this one and we know that the table is symmetrical, you start with this first value. You'll see that it's 1.886, but you need to use the symmetrical one, which is minus 1886. So in order to solve the k value, we have the square root of 2k. Remember, this is what we have here. And this is equal to minus 1.886. So you just need to change the values around by the square root of 2. And k is equal to minus 1.334.